This is the last section of the electrostatics conceptual notes. This is number 51. Suppose a hollow metal sphere has a large number of extra electrons on it. The extra electrons will always be on the outside. So even though these are positive charges, if you had electrons, we know that they would only be on the surface of the sphere. They would not be on the inside. Number 52, the electric field outside of that same Van de Graaff generator may be huge, but remember on the inside, the electric field is absolutely zero. We've talked about all the charges wanting to be really far away. A woman's hair stands, so here's a little girl. You can tell her hair is really standing up there. The reason her hair stands up is if you remember, each one of the strands of hair has little charges on it, so we'll just say that these are negative. These are negative, and because like charges repel each other, her hair will stand out. So each strand of hair has that same charge, and because they do, they stand way out. For number 54, it says the Van de Graaff generator is a machine. Remember, this one is a pretty large Van de Graaff generator, probably generate upwards of 450,000 volts. So it does build up high voltage, but it doesn't hurt you because it has a very low current. Number 55. After you rub a balloon on your hair, the balloon likely is charged with several thousand volts. That's pretty believable, especially with what we've done with the Van de Graaff generator, getting those up to somewhere around 250 to 300,000 volts in our room. Number 56, a beam of electrons accelerates from the back of your TV set to the screen. So this is the old style TV that had the big tube in it. In order to make the beam hit the top of the screen, there is a plate, and the plate has to be positively charged. Because the electrons are negative, if we want it to bend up, we would have a strong positive charge here. If we want it to go straight through, we wouldn't put any charge on it. And if we want it to bend down, the bottom plate will have a bigger positive charge. And that's how they were able to aim that wired across. Number 57, two parallel plates are oppositely charged. The left one is negative, the right one is positive. They want to know which direction is the electric field. If you remember, we always go from positive to negative. Always from positive to negative. So for this one, we would have from positive, negative, or in our example here, it would go from right to left. For number 58, electric potential energy per charge is basically just electric potential. The charges cancel, and that just leaves you with potential. For number 59, electric fields between two oppositely charged parallel plates means the plates has the metal plates. We know that those electric field lines are straight lines, and they are very evenly spaced out. So we see how straight they are here, and we see that they are all evenly spaced out. Sorry about that one. Number 60, the electric field inside an uncharged metal ball is zero. If the ball gains a negative charge, the electric field inside the ball will still be zero. So no charge inside a charged sphere ever. Charge is only on the outside, so your electric field is really only on the outside. And that is the end of the conceptual questions for electrostatics.